We have following learning objectives in today's lecture. We want to know first that what is value at risk or VaR. We also want to see that how we can interpret VaR. And finally, we want to see that how we can compute VaR statistics with different probability levels and time horizon. So first we need to know that what is the VaR, value at risk. This is a risk assessment technique. So we use it as a technique to assess the risk of our portfolio. So many financial institutions, fund managers use this popular technique to assess the risk of their portfolio, and it is used to evaluate the probability of a significant loss. And main assumption over here while using the VaR is that the returns are normally distributed. So let's understand it with some example. So the actual data from the investment in S&P 500 index fund suggests that from 1926 to 2015, the index fund, S&P 500 index fund, has given the average annual return of 12%. So the average annual return of the index fund was actually 12%, and the standard deviation is 20%. This is the average annual standard deviation. Both are in terms of on annualized basis. So it means that if the returns are normally distributed, so it has a distribution shape like this, where the mean is 12%, and how much one standard deviation away we are on the left. So on the left, one standard deviation, and on the right, one standard deviation, means you have to add the standard deviation in the mean. So you can move to the right hand side from the mean, which is one standard deviation, 32%, 12% plus 22%, it will give you 32% over here. And from 12%, if you will move on the left, you have to subtract the standard deviation, which is 20%, and this will give you an 8%. So this is one standard deviation, and we know that with the assumption of the normally distributed return, it's almost 67% of the returns lie within this one standard deviation area. So 67%. So how much lie outside? It will be obviously 33%. 100% minus the 67%, and because there is a symmetric distribution, so both of these areas will have equal probability. So the area under this curve, this curve and this curve over here will have the will be the same. The area on both side will be the same, and obviously it suggests that 16.5% probability is over here and 16.5% probability is over here. So what does it suggest? It is suggesting us that if we assume that the same return pattern will behave into the future, because we only have the historical return at this time, but if we'll go into the future, then over the next year, if we own S&P 500 index, then 16.5% chance is that we can experience a loss of at least 8% or worse, because this is the area, this is the probability over here. So over the next 1 year, the chances are that we can experience a loss of 8% or worse, and that chance or that probability level is 16.5%. So we can write now the VaR statistics with this given situation as probability with the probability level of 16.5%, the return of the portfolio can be So it is actually minus 8%, means that the minimum expected loss will be 8% or more than that at a probability level of 16.5% over the next year. So this constitutes a VaR statistics, this probability plus the minimum expected loss. Now, what if the situation is that rather 1 year, we are concerned about the next 2 years? So we want to see that over the next 2 year, how much we can lose, say at a probability of 5%, means with the 5% chance, how much we can, what is the minimum expected loss, or even worse than that. In that case, if we are talking about over the next 2 years, then we have to convert the return, the mean return of the portfolio, which is the S&P 500 in that case, according like as per the 2-year basis. So we have to change it to the average 2-year return, and also the average 2-year standard deviation we have to compute. And in order to do that, we have a generic formula. So we can compute the 2-year average 2-year return by multiplying the annual return with time t. And what is the annual return over here in this case? We have seen that it is the 12%, right? So 12% is the annual mean return, and in order to convert it, into the 2-year return, average return, we have to multiply this annual return 12% with 2. If this is 3 years, that we want to know that what is our minimum expected loss over the 3 years, then the t will be 3. Or if it is, say, for we want to know that what is our expected loss over the next 6 months, then it will be 6 divided by 12, because then it would be a fraction of the year. So 12% multiplied by 2, it will give us 24%. And the standard deviation, we have a relatively different formula for that. So we will multiply the annual standard deviation. Remember, this is not I was just highlighting earlier. So it will be multiplied by t. So now in that case, we will multiply the standard deviation, annual standard deviation 20% with the under root of t. So under root of t, which is 2. And if you do this calculation, you will find that it will be 28.28%. So 28.28%. So what we have done over here, we have converted the average annual mean return into the average annual return into the 2-year average return, and likewise we converted the average annual standard deviation into the average 2-year standard deviation. So now if the question is this, that at 5% probability level, like with 5% chance, what is the minimum expected loss for investing in S&P 500 index fund over the next 2 years, then we need to find the VaR statistic like this. So probability with the 5% chance, right? And the return of the portfolio. We want to know that what we can find something over here, and that we will be able to find only if we will be able to find that where we will actually lie on the distribution, like on the distribution of the return of the S&P 500. So in this case, if you see now, we have this thing, this symmetric distribution, but this is for now for 2 years, because we wanted to know our minimum expected loss over the next 2 years at 5% chance level. So it means that mean is somewhere over here. So mean is somewhere over here. So mean is 24%, which we have just calculated for by converting the annual average return into the average 2-year return. So, and the standard deviation, obviously you have to subtract from 28.28. So you will, if you see, we are concerned about the left hand side, not on the right hand side, because we are concerned about the loss, and VaR is the risk assessment technique. So we are concerned about the loss which lies on the left hand side of the distribution, rather on the right hand side of the return distribution. So in this case, now say if this is the 5%, so the area under this curve, only this part of the curve, is 5%, right? 5%. So question is this, that with the 5% chance, what is the minimum expected loss? This is the minimum expected loss. We want to find out this level of return, or worse than this, right, over the next 2 years. So this was actually the question. And in order to solve this, we first need to find the z-score, because z-score will give us the standard deviation, exact standard deviation, which we need to multiply. Z-score exactly give you, not the standard deviation, z-score will exactly give us the number or magnitude with which we have to multiply this standard deviation and come to the level where onward the probability area, or the area under the curve, or the probability, will be exactly 5%. So that is actually our aim, to find out that what is that minimum return. But without z-score, we will not be able to multiply it with the standard deviation and subtract from the mean in order to come over here. So in that case, we have to see that what is 5%. We know 5% in decimal is 0.05. So you need to go on to the z table and see that where does it lie. It is lying, if you see, right over here, with somewhere in between these two numbers. Can you see that? So minus 1.6, this one, and this one, 4, and minus 1.65. So in between, if it is lying somewhere over here, right, the 0.05, then it is minus 1.645. So z score is 1.645. If we'll multiply the standard deviation with this number and subtract it from the mean, we will be able to find the return, which is the minimum expected loss, because then from this return onwards on the left hand side, the area will be exactly 5%, right? So let's do this calculation really quickly. And so it suggests that the expected loss, expected return of the portfolio is equal to 24% minus 1.645. So this minus is actually the same over here, this minus, all these minus, right? This minus is just suggesting that we are on the left hand side of the mean, and because we are concerned about only the loss. So 24% minus 1.64 into the standard deviation, 28.28%, and this is this standard deviation. If you calculate it, you will get minus 22.52%. So this minus 22.52% is the answer. So now VaR statistics is suggesting that with that there is a 5% chance in the next 2 years that the minimum expected loss for investing in this S&P 500 index fund, based on the historic data, the loss will be at least 22.52% or more than that. So this minus is suggesting the loss. So normally the fund managers are interested to know that the minimum expected loss at 1% level, 2.5% level, and 5% level. So in this case, in the generic way, we can write it as the probability of the return of the portfolio over T time period horizon is given as less than or equal to expected return of the portfolio of multiply by T, and this is what we have done, remember, by multiplying and converting the average and annual return into the 2-year return by multiplying it with 2 over here, this thing. So this is the same thing over here, this thing, and then subtracting it with the appropriate z-score product and the standard deviation. So minus 1.645, which we have done, multiply it with the 2 years average, average 2-year standard deviation. So this is the annual standard deviation, multiply the T. So this will give then the average 2-year standard deviation, right? So this and this will be equal to 5%. So if this 5% will change, obviously this z-score will change accordingly. For 1%, for example, this should be minus 2.326 rather minus 1.645. Likewise for 2.5%, it should be minus 1.96 rather minus 1.645. This conclude my lecture on the value at risk.